morning. My name's Rhys. I'm an operational manager at Calm Solutions. I've been with Calm now for 5 or 6 years. I was actually the 5th employee of Calm, and we've got over 100 now, so it's a growing business, and hopefully it'll grow and grow and grow. So today I'm going to speak to you about our systems that we've got in place to inspect, maintain, interrogate data for various assets. That might be underground assets, as Bob just alluded to, or linear assets, so pipe, sewer lengths. So what do Calm do? I just touched on, we not only provide operational solutions, but IT solutions for this industry. Two of the systems that we've got and we are using right now, namely AIMS and Sewer Viewer. AIMS stands for Asset Inventory Management System, and that concentrates on a lot of below ground assets, CSOs, flat valves, penstocks, various type of stuff. AIMS actually allows data to be sent live from site into the system, where it then interrogates it, reports on it. All of this is live for the client to see, and it allows them to be proactive rather than reactive, which we all know is a massive saving and a big help. As well as AIM Sewer Viewer is very similar. Data is uploaded live from site, CCTV footage, manual surveys, various things like that. Once again, it goes straight into the system live. The client can see it there and then, so it allows them to make decisions in real time, being proactive rather than reactive. Touches on our solutions there, which is the data collection, secure and robust solution design. We are compliant with the 27001, so all our systems are checked and accredited to that standard. Is it a bit small on here? There's various things there that I've already touched on. So on-site resolution of issues, that's our operational support. So it's our guys that are actually out there collecting a lot of this data. If they can fix it there and then, they will do. However, a report will still be sent through to the client to allow them to do whatever reports, investigation they need to find out what the bigger problem is, put a fix in place. Enhanced asset management, so gone are the days I'd like to think of paper copies being stuffed into a cupboard somewhere, and DVDs where people have to sit down and watch them for half an hour to find 2 seconds of defect on a pipe. Sewer Viewer, for instance, allows that to be done with a couple of clicks of the button. So if there is a defective on a length of pipe, you can click on a button, it'll take you straight to that defect, allowing cost saving, because you're saving you time, obviously. It seems pretty simple in my head, but there was a solution that needed to be put in place, and it thankfully has done. Significant cost savings, obviously, as I just discussed. It's obvious to see when you actually see the system and sit down and work with it. There are lots of cost saving. AIMS, at the moment, the client that uses AIMS, they've built the system along with us, and they've allowed us to kind of direct them where we believe they needed to be, because they didn't know. But the things that we thought needed looking at was condition of assets, serviceability of assets, and then ultimately the health and safety issues around that asset. This is our guys going out. They do man entries, they're clambering down ladders. So any of them points there that are defective with regards to the asset instantly gets reported to them, allows them to put a fix in place if needed, or if they believe to be needed. All the asset data capture is electronic. We've completely done away with paper copies. We believe that's the way to go. So there's various apps that have been designed, and they're robust, they work, allow various pictures. I know that some companies have problem sending pictures through via apps and what have you, but ours work. Availability capture, photographs, videos, read-ins, location, and sensor information. So there's various bits of data we understand that need to come back in from site. Well, our apps allow that to happen. Again, our operational support, they are out there doing the work as well as inputting the data from site. This is just one example of an asset that they look after. As you see on the left-hand side, the copa sacks are full. And then we've gone out, we've seen there's a problem, we've reported that problem via the app. However, we had spare copa sacks to fit right first time, kind of fix first time. Again, we'll touch on the ODIs there. Improvement asset performance leading to reduction of flooding and pollution, ultimately success in the ODIs. As I touched on earlier, when the data comes back into the systems, AIMS and Sewer Viewer, it gets analysed, it gets graded, which again, a couple of clicks of the button, the client can see all of their high grade in, all of their low grade in. Cost saving, the low grade ones are all okay. We can maybe reduce the frequency on them, so there's no problem there. The high grade in, maybe up the frequency of the inspection, up the frequency of the maintenance, or get out there and price up a fix to be rectified there and then, and for a longer term. The systems also allow management reports and managers to analyse the data. There's various reports. As long as the data is there, I keep on saying this when I go to these type of things, but whatever data we've got in the system, we can report on it. We can build reports to report on whatever data you want. Ultimately, the data coming in and the reports will be directed from the client and whoever's using the system, whoever's assets are in the system. Some cost benefits, but the additional benefits of our systems there is a positive impact on customer service, carbon reduction, because we're doing it right first time. There's no need to go back out and revisit the asset multiple times. Improved ODIs in ways of less pollution incidents, less customer impact. Compliance, so a lot of the assets that we inspect now have permits. The data that's collected allows them permits to be compliant. Operational performance of the companies that we're working for, we like to think that we help them and improve their operational performance and environmental impact. So if we're proactive rather than reactive, then that means less pollutions, less pumping station failures, less impact on the environment, which is obviously a good thing. I've talked about our systems. One of our survey offerings is laser scanning. Elliot, who's my colleague, is the expert in laser scanning. So from a system point of view, and from my point of view, that's me done. So thanks for listening. I'll pass on to Elliot, and then once he's finished, we'll both come back up for any questions. Thank you very much.
Hi, as Rhys was saying, I'm Elliot. I also work at Calm, but I look after the laser scanning side of the business. That picture there is the scanner that we currently use. We initially purchased it around 2 years ago with the intention on mainly focusing on pipe bridges, as there's a lot of flooding in the Carlisle area, and there was a lot of worry about the potential of the failure of these assets because of the rising floodwaters. Since then, we've moved on to scanning pumping stations, detention tanks, CSOs, kind of all kinds of assets really. And one of the main things, I want to just leave this picture up because that tripod that we use, we actually invert. So we can do below ground scans from above ground, so it kind of reduces the health and safety risks and any other risks that may be associated with actually performing the man entry. So laser scanning itself, those of you that aren't familiar with the process, is, if you think back to that picture I just showed you, that is the laser scanner that sits above it. That scanner then rotates with a mirror over it that also spins. It spins at a very fast frequency, and the laser shoots out, bounces off other solid objects and comes back, and that is how it kind of builds the image from the time it takes from the laser scanner from the laser to leave the scanner to then return to it. The applications are kind of well, sorry, the definition is kind of what I was just getting at there, which is the measuring distance angles at a high rate of speed using a laser scanner. The scanner that we use is terrestrial. That image is from it's actually from a substation up in Dornell, just south of Inverness. Those of you that don't know much about laser scanning, the image you normally get from a laser scanner is black and white because colour doesn't normally come into it. But what we do is the product we have also has a camera on it, so we are able to overlay the images that are taken to produce images of that quality. The same about the applications. In all industries really, they can be used for renovations, producing as-built data, any infrastructure that may need either inspections or during the process of building. It kind of gives you almost an asset history and a life cycle. A lot of what we do these days is trying to integrate more within the BIM side of things, because we are effectively creating a digital twin of a physical asset. So the process starts with the tripod that you saw earlier. We'll go to site, where above, below ground, wherever it is. We will then set up that tripod at multiple locations around the asset. We sometimes use things like that, like reference spheres or reference planes. These are objects that don't move in between different scans, so that's always a constant point that we can use when we're patching the different scans together in the project. As it says there, the product we have has a 150 metre range. It's just short of 1 million points a second with a plus or minus 1 millimetre of accuracy. If the substation that I was talking about, if you can see the top right, well, the top two pictures, that kind of shows the amount of setups we did. Each scan roughly takes 12 minutes for that scan itself. It can be as much as 2 hours, or it can be as little as I think I'm sure it's about 3 minutes per scan, depending on the accuracy that you require and the resolution of the images. From the scans, we're able to create something like that, which is a point cloud. That is effectively what you would use to then put into different programs such as Revit or AutoCAD, or even you can even leave it in the laser scanner and just use it as raw data, as the quality is still there. As I just touched on, from these scans you can either trace directly over it in Revit, and then if you want you can add all the further data, so inspection records or service histories, or even like hyperlinks to where you bought new parts from. But the more innovative way that we are currently doing is just, as I put there, is just sharing the data that we have via the cloud, and you're just using the raw data. It's a faster way of doing things. You still get the same accuracy. The only difference is some companies do prefer to use things like Revit, so we give you both them options. From that image, there was something else on there, but as I had a problem earlier, it seems to have disappeared. The picture on the right is what's actually there. The picture on the left is when we've kind of reverse engineered it a little bit, so we've got rid of all the power equipment in the middle. So if you can imagine, you could then use that to, if you wanted to completely redesign it, that you could just cut out what you don't need and then put in your own, either if you have a scan of it or even like foreign source, such as, again, as I mentioned, Revit. You can just pull in other models and kind of fit them how you want them. And then other things you can do is you can mesh over an object. So if I did a full scan of this room, but we only wanted one table, we could just mesh over the table and the rest of the data will be lost, so the data packages are much smaller then. Well, not lost, sorry, just removed. And you can just focus on that. Then you could even, if you wanted to move that into a different project, you can then use the same mesh model that you've just created and put that into a different project for further design purposes. And I don't know what's happened there, but that is pretty much it. Anyway, have we got any questions for me or Rhys? Sorry. Oh, happy days.
Can you put this sort of thing on a camera? Is that quite get us to do less of culverts, for instance?
On a camera?
On a camera.
Such as like a push rod or a crawler?
Usually culverts on the railway, for instance, through like 12 up to 9, 12. But the air,
traversing down through the culvert.
And taking physical measures, could you translate this onto a camera?
Depends how long it is. However, I have looked at some technology recently, and we're looking to purchase where a similar type of thing is going to be on a drone, and you fly the drone down the culvert. So I have put a business case into the company to look
There are
at.
cameras, but they're really
Yeah.
it's a miss.
Yeah.
Yeah, well,
It is doable. We have done a project.
Yeah.
One to go with it.
we did one up in Cumwinton underneath the M6 where we were able to, but we could see from one end to the other, so the scanner could see each other, so we were able to patch it together and give all the measurements, but depending on, I don't know if the culvert's got bends and all sorts, it would lose the data then, unless we could traverse and put different points in, but I don't know whether...
There'll be, as I said, the fix, because I've been asked that before, and the fix is to, if the culvert's big enough, just fly a drone down, and the drone with this technology attached to it kind of gives you all the points, so it is available, and we are looking into it. Yeah. Thank you.
Go on, Norman.
How cost effective is it for, say, producing, say, manhole drawings and the like? Or is that something you don't use as?
We do.
Yeah.
We do. Cost effective, it's hard to put an actual figure on it, Norman, but what I'd like to say is at the moment, what we're finding with the clients we're working with now, they haven't got any as-built, so they might have, but they've tucked away somewhere for no one to find. So using this type of solution and having it electronically stored in our system, it's there forever and for anybody to get access to. So
You don't need to revisit site once it's done once.
I was thinking, the water companies are inheriting a lot of private sewers with various manholes on, and then also probably pumping stations as well, and they used to be
the accuracy of the data that the scanner provides, it has been used to I was talking to a chap earlier about tank sewers and being able to work out the storage volume of that tank sewer. Well, we have actually used the data that's provided for that, and it's accurate. It works, so it does help with that as well. Like the storage volumes and overflow volumes and all that. Anybody else? Thanks very much,
Cheers.
guys.